Acha, this tutorial is going to be on the last question of the practice question cassette. It's concerned with a graph and uska MST ban raha, and we're going to see properties related to it. So the graph G in this case is an undirected graph with weighted edges. So the MST is going to have to find the minimum weight of the edges. The first statement says, let E be the edge with the minimum cost in G, then every minimum spanning set of G uses contains the edge E. ठीक है, फ़र्ज़ कर लीजिए हमारे पास कोई ग्राफ था G और इसके अंदर जब हमने MST बनाया it came out looking like this. ठीक है, now U and V are connected by the minimum edge. So let's say in the original graph, what the original graph looked like was actually like this. ये इस तरह था. फिर ये भी है आपका, यहाँ पे भी हो सकता है, फर्स्ट कर लीजिए यहाँ पे भी हो सकता है, यहाँ पे भी हो सकता है. एंड दीज टू हैपन टू बी कनेक्टेड बाय एन एज, और इनके दरमियान जो एज था दैट वाज एक्चुअली ई स्टार. दिस वाज द लोएस्ट कॉस्ट वाला एज. द MST that we made eventually didn't actually use that edge. हम कोई और एज इस्तेमाल करते थे to connect the entire tree. ठीक है, we'll see exactly why this can actually always find a better tree while using हमारा minimum cost edge. हमारा जो MST बनेगा उसके अंदर सारे हमारे जो edges होंगे they will be connected, which means there will be a path from every vertex to every vertex, right? Now in this particular MST, the path is from here to here. If we haven't used the minimum cost edge, then what we can simply do is we can remove any edge in between this path from U to V. तो हम कोई भी edge हटा दें, इसमें से आप ये वाला हटा दें या आप ये वाला हटा दें, कोई भी हटा सकते हैं आप. जब आप हटाएंगे, then our graph will become divided into exactly two components. When you remove one edge, it's obviously, like naively you can see, बिल्कुल हमारे पास दो ही components बनेंगे. Now, if you've removed that edge, you have to make a minimum spanning tree, which means you still have to add one more edge to connect both these components. And you would like to connect these components. What you do is you just simply connect them using that minimum cost edge. Now, since this was the minimum cost edge, the cost of ये वाला edge was definitely more. इसकी ज़्यादा थी. So इसको हटा के जब मैंने ये बनाया, तो अब मेरा फिर से minimum spanning tree तो बन गया. Everything is connected. And what I've done is I've further reduced the cost. So in any case, if I ever end up making a minimum spanning tree जिसके अंदर the minimum cost edge is not used, what I can do is I can find a path in my MST from U to V. I can remove any edge from it, which will divide my tree back into two components, and I need one more edge to reconnect them. I reconnect them using the minimum cost edge, and thereby I found a lower cost MST. And this will always be true because the edge that you've removed will have a higher cost than the minimum cost edge.